Okay, for this next video we're going to be looking at the vertex normal and pixel normal nodes. So we've had a look at how to get object position out of a material, or into our material I should say, so position and things like that. And what this gives us is the direction the surface is facing. So if I plug in the vertex normal and just unpin here, which way are our surfaces facing, and it gives us this in world space. That's what the WS stands for here. So here, this face on this part of the cube is facing solely in the X direction, so the vertex normals are facing that way in world space. Same here, green and blue. If we do a sphere, it's going to give us nice smooth normals, and it's calculating it per vertex because we're using the vertex normal. If we were to compare this to pixel normal, it's going to look almost exactly the same. In fact, it should be exactly the same because we've not got any per pixel information in here. So for example, if I plug in my normal map, now we can see that the pixel normal result is giving us the normals per pixel, and so it's taking into account the normal map, and you can see we get that information in here. If I compare that to the vertex normal, now we've got the normals applied, so it's being involved in the lighting calculation, but the vertex normals is giving us the surface without taking that normal map into account. Anything per vertex is cheaper, but there are advantages to this, and one of the worked examples we'll be doing later is a snow shader, and that will take advantage of the difference between these. So we'll get a nice kind of per pixel normal in a transition period, and then we'll get also a lumpy snow on top. So using these in different ways. It is much more expensive to do it per pixel, and also we can't use the pixel normal to also edit the normal. So for example, if I just make a quick setup here, and I'm just going to blend between pure blue, which is the flat normal, and the up axis. Not the up axis, it is, in this case it's a flat normal, and if I blend between these based on, let's say, a dot product of the vertex normal and up, there we are. So this is basically the example we'll be doing later, but this kind of works. So here we've got the brick normals at the top of our object because it's facing upwards, not here at the sides, and then inverted at the bottom, and that works fine because we're using the vertex normals. But if I try to use the pixel normal, we'll get an error because we're trying to basically read from this channel and then also write to the channel, and so it says here invalid node. So if that comes up, just watch out for that, and we might encounter that later. As I say, we'll be covering this in a lot more example in the worked example where we do the snow up shader. Okay, let's just put this back to where it was, and worry about that later. Vertex normals. Similarly to the normals, we have the tangents. So the vertex tangents are going to be the direction along the surface. So the normal outwards from the surface, tangent across the surface. And then if you needed the third axis, what would be called the bitangent, you can just cross these two and you'll get the other direction instead. So not as useful for sure, but for some complicated things you might use vertex tangents. Believe you might use it with anisotropy to do hair shading, that kind of thing. But yeah, that's what it's doing. So vertex normal, just the surface without any textures. Pixel normal with the normal map applied, but there are limitations to that. As again, we'll be covering this in a lot more depth, or in some worked examples in some of the later lessons as well.